A lot of stop and start here. I'll give you an example, you'll work through it, and then I'll go over the correct answer with you. So here's the first one. Let's do some stop and start, and I'll go over it. All right, so, I'm sorry, here's the first one. So let's go over some stop and start, okay? All right, so in solving this, we said before, look, here's our goal. We'll do exactly what we do with equations. We've got one big exception. If I multiply, divide by a negative, we switch the direction of the inequality. So I get 2x plus 6 is less than or equal to 4x plus 12, okay? Next step up, I'm going to subtract 2x from both sides because I want to start with the smaller number of x's. And this is clearly an opposite side situation. Gives me 6 is less than or equal to 2x plus 12. And then I subtract 12 from both sides, and I get negative 6 is less than or equal to 2x. And again, we talked about the symbol. Dividing by 2, I get x is less, negative 3 is less than or equal to x. And here's where, before we said the really important thing is we always want the variable on the left. If you notice, our answer has the variable on the right. So I'm going to switch it. I'm going to put the answer, the variable on the left instead of on the right. But here's what you have to remember if you switch. If I point to the negative 3 here, I have to point to the negative 3 over here. And that's pretty easy to remember because when it comes to graphing, where it points is very important, and we want to keep that pointing the same. Here, it points to a negative 3, so over here it better point to the negative 3. So whenever you switch sides and you put the x from the right to the left, just look at the number and make sure the inequality continues to either point to the number or point to the x. All right, so switch the direction of the inequality, you end up switching the sign, okay? And next is, if we want to express this in interval notation, I'm allowed to equal the negative 3, so I use a bracket. We said before, you never, ever, ever use a bracket with infinity. It goes on and on forever to infinity. And my graph looks like that. Negative 3, closed or filled in circle. You could use a bracket if you wanted to. And then going on out to negative 3. So here's another one for you to do. Go ahead. Okay, we'll stop and start action here. Distributing. Oh, that should say 2x plus 2. Oh, that's a mistake right there. That should say 2x plus 2. Oh, Lord. Little bit of an error there. So I made a mistake. How do I take care of that? Well, let's pretend instead of 1 in the parenthesis, it said 1.5. All right, minus 2x from both sides. I get 3 is greater than negative 3x plus 12, just showing you we can do it again. Subtracting the 12, I get negative 9 is greater than negative 3x. Divide by negative 3, and I get 3 is less than x. Keep in mind, because I divided by a negative here, I switched the direction of the inequality. That's what we went over before. But then, if I want to switch to proper notation where the x is on the left, which I just did, if it points to the 3 over here, it's got to point to the 3 over here. That's how you tell to do it right. I do apologize for that mistake with putting 2x plus 3. That's because I based this slide off of the previous slide. I didn't catch that mistake as I went through it. Sometimes I do stuff like that. I never got 100 on a state regents exam. Always got really good grades, 97, 98. But I never got 100. This is why I do stupid mistakes sometimes. My old teacher used to say, down bow Monday, and he was right. Last but not least, in interval notation, it looks like this. I'm not allowed to equal the 3, so it's a parenthesis. Goes on out to infinity, and there is my graph, okay? So if you didn't get this exactly right because of my mistake, just see that you were doing the steps the right way and you were aware of what everything was, okay? Solve and graph the solution on a number line, and so on. So here's another opportunity for it. So let's stop and start. Okay, I'm distributing the 4. This time I add the x to both sides. Much simpler and easier to do. 5x plus 4 is less than 19, subtracting the 4. 5x is less than 15, dividing by 5, and I get x is less than 5. Keep it that way. Don't go changing anything. The x is already on the left. Keep it that way. I like it like that. I like it like that. Okay, how do I express this in interval notation? Well, since the x is less than the 5, the arrow is going to go to the left. So that means we're dealing with negative infinity, not positive infinity. So I'm going from negative infinity to 5. Okay? And there's my solution, or the graph of my solution. Okay. Just want to cover real quick the idea of some inequalities with no solutions. So I'm going to quickly go through some examples of this. This isn't something you do very often. Distributing the 5 on the right, you get 5x minus 15. And then if you subtract the 5x's, you get 0x is less than negative 15. This is absurd. It makes absolutely no sense. Since it makes no sense, there is no solution. No sense, no solution. Makes that ironically makes sense. So if 0x is less than negative 15, what would you do next? Divide by 0? That's undefined. It makes no sense, so there's no solution. I like math when something doesn't make sense, that there is no solution. And that makes sense that no sense means no solution. That's my warped sense of humor. Here we go. 4x plus 8 is greater than 4x plus 15. Subtracting 4x from both sides, I get 8 is greater than 15. That never happens. Makes no sense. Since it never happens, it makes no sense. There is no solution. All right, next up, inequalities with solutions where everything is a solution. Distributing the 3. 3x plus 3 is greater than, little combining like terms here, same side, same operation, 3x plus 1. Subtracting the 3x's from both sides, I get 3 is greater than 1. That's always a solution. So, if it's always true, it's always a solution. Anything works. Okay, a couple of more applications, and then we are done with our quick study of inequalities until we come back and hit them every week so that we remember what they're all about. You're choosing between two telephone plans. Plan A has a monthly fee of $15 with a charge of 8 cents per minute. And Plan B has a monthly fee of $3 with a charge of 12 cents per minute. How many minutes of calls in a month make A the better deal? Stop and start. Okay. Better means it costs less. So, in the first case, I have to write an expression, which is 0.08, that's 8 cents per minute, 0.08 M, plus $15. In the second case, it's 0.12 M plus $3. And I want A to cost less. So I do 0.08 M plus 15 is less than 0.12 M plus 3. And I solve it. Look, it's the same thing as doing equations, just a little different symbol. Minus 0.08 M, that gives me 15 is greater than 0.08 M. I subtract 3 from both sides. I get 12 is greater than 0.04 M because 12 M minus 0.08 M is 0.04 M. Then I divide by 0.04, and when I do that, I get 300 is greater than M, or M is less than 300. So for 301 or more minutes, Plan A works out to be a better deal. And our last application question, begin, stop, and start. $80 points. So it says here to earn a B in a course, you must have a final average of at least 80. On the first 3 exams, you have grades of 82, 74, and 78. The final exam counts as 2 grades. What must you get on the final to earn a B in the course? So 80 points average on 5 tests, the 3 that we see, and then the final counts twice. That adds up to 400 points. 80 times 5 is 400. You could get more than that, but you have to get at least 400 points. 82, 74, 78, they add up to 234 points. And the final counts twice. So 2 times, I could have said F, I probably should have said F. 2 times N plus 234 must be greater than 400. That's why this is an inequality. Subtracting the 234, I get 2N is greater than 166. Dividing by 2, I get N is greater than 83. Which means, what grade must you get to earn a B on the course? If you're greater than 83, can you be 83? You have to get at least an 84 on the test. Okay, so we have just run the course now of a good solid beginning with inequalities. And the last thing that we're going to do as part of this lesson is a pretest. And the pretest I'm going to make a separate video about after this one.